Dear maths enthusiasts, we meet again for another comprehensive maths session to learn differential calculus. We will solve 4 differentiation questions progressing from simple to difficult. We will discuss the basic differentiation rule and chain rule differentiation, also known as function of a function rule. Consider this first exercise aimed at demonstrating the basic differentiation rule. Pause this video and try to solve this exercise if you already know how to apply the basic differentiation rule. You're required to differentiate with respect to x. It is okay to differentiate separately each term in the function and add together each differentiated term to give the overall sum of differentials. Knowledge of laws of indices is a prerequisite for becoming a pro in differential calculus. The link to full video tutorials on the laws of indices can be found in the description. Also click on the card at the top right-hand corner of your screen to see the full videos playlist. Watch till the end to see the strategy for achieving a simplified differential form. The answer to this exercise is 12x squared minus 10x squared. Consider the second exercise aimed at demonstrating both the basic differentiation rule and the chain rule differentiation methods. Pause this video and try to solve this exercise if you already know how to apply the chain rule differentiation. You're required to differentiate with respect to x. The chain rule differentiation method requires substitution. The substitution is important because the differential of the exponential function in this exercise cannot be found in the standard differential table. Let u be equal to minus 3x plus 4. Solve for dy du. Differentiate exponential power u to get exactly the same as exponential power u. This is the equivalent found in the standard differential table. Next, solve for du dx. Recall that u is equal to minus 3x plus 4. Differentiate the function u to get minus 3. Watch till the end to see the strategy for achieving a simplified differential form for du dx. Now, for the last step, apply the chain rule differentiation formula. Replace dy du and du dx with the results of differentiated terms. The answer to this exercise is minus 3 multiplied by exponential function raised to power minus 3x plus 4. Now you've learned how to solve chain rule differential calculus. Consider the third exercise aimed at demonstrating a hybrid of the basic differentiation rule and the chain rule differentiation methods. Remember to change the square root to fraction power. This index form is necessary for successfully applying the basic differentiation rule. Watch till the end to see the strategy for achieving a simplified differential form for f'(x). The answer to this exercise is 3x squared plus 1 minus 1 divided by the square root of x plus 1. Let's solve the fourth and last exercise aimed at demonstrating a hybrid of the basic differentiation rule and the chain rule differentiation methods. Be patient and keep an open mind as this exercise is a bit of a stretch. It is a good practice to split up f of x, especially when the exercise has too many complex terms. You can solve one term as f1 of x and another term as f2 of x. Then add the differentiated terms to get f prime x. Watch till the end to see how I have solved for f1 prime of x. Now, we progress to solving for f2 prime of x. Apply the chain rule differentiation formula. Let u be equal to x squared plus 8. We need to solve for dy du. Keep an eye on the square root of u. Change the square root to fraction index and reciprocate afterwards, so that it is easy to apply the basic differentiation rule. Continue watching to see my result for dy du. Now, we progress to solving for du dx. To get the result of dy dx, we need to multiply the differentiated forms for dy du and du dx. This result is the same as f2 prime of x. Continue watching to see how I'm reorganizing the result by bringing similar terms together. We are almost done with this exercise. We now need to get the final result for f prime of x by adding f1 prime of x and f2 prime of x. Congratulations for reaching this point in the video. You are already becoming a calculus pro. Please like, comment and share for more reach. Subscribe for more math tutorials videos.